Good afternoon, everyone, and welcome to Griffith Observatory. We are so happy that you're here, and what a lovely audience, full audience, on this wonderful anniversary of the Apollo 11 landing on the moon. We have a full slate of talks today, just half-hour talks every hour on the hour. Today's talk at noon is the mysteries of the moon. And this talk is not so much about exploring the moon or sending astronauts to the moon or building habitats on the moon. It's really about the moon itself as an astronomical and a geophysical object and what it is, how it got there, and what are its mysteries. Later, at 1 o'clock, we have a talk about hoax, no hoax. How many of you people think the whole Apollo thing was a big hoax? All right, we'll work and try to change your minds. Oh, that was a joke? Okay, I'm glad. As I said in the last one, Buzz Aldrin will deck you, so you better be careful. And then the last two today are about the future, our future on the moon. Near-term future, the Artemis Program, which is the follow-on to Apollo. How many of you have never heard of the Artemis Program? So about 30%. And then our long-term future. 50 years from now, as opposed to 50 years ago, what will it be like? Will we all be living on the moon? Will there be manufacturing on the moon? Who can say? We'll kind of explore the possibilities and the limitations. All of these presentations are given by your All Space Considered crew. It's the first Friday of every month. We have a monthly show about latest news in astronomy and space. So if you want to know what we're up to, follow us on All Space Considered on any of your social media, and we'll tell you all about what we're up to. So, without further ado, let me move on to the mysteries of the moon. I think the first thing that might be mysterious for people looking at the moon is why does it go through phases? It doesn't look the same every night, and it doesn't rise at the same time every night. And so this is a mystery, and was a mystery for the ancients who didn't really have a proper model of the Earth-Moon-Sun relationship. But in fact, now we know, this is just kind of a cool video of the phases, the changing illumination on the face of the moon. But now we know that there is a very simple reason for the change of the phase. It starts as a crescent, grows to full, and then shrinks back down to a crescent, seems to disappear, and then the whole cycle starts over again. And that's simply a matter of geometry. The sunlight comes in, it hits Earth, this is daylight, and as the moon goes around the Earth here, the same face, the face that faces the sun, is always lit. But when it's in different positions, we see different faces of it. So when it's full, the moon is opposite the sun, and it's getting fully illuminated, and we're seeing that. But when it's, let's say, a little crescent over here, we're just seeing the teeny, teeny crescent. Does that make sense? So I see there are a lot of young people in the audience, so just in case you're wondering why the moon changes shape and why it rises at different times, it's this simple explanation. The other thing the moon does that kind of puzzled people at first is that it seems to affect the height of water. It's what's known as tides, and that's because the moon exerts gravity on the Earth, and it pulls on the oceans, when it's in the same direction as the sun, you get these like lobes. Here it's high tide, here it's low tide, because the water on Earth's oceans doesn't just go perfectly around, it kind of goes smushed into a football, elongated in the direction where the moon is, and that's what leads to tides. One of the interesting outcomes of all of this is that you may not know that the moon is moving away from us every year. Every year it goes about 1.5 inches farther away from Earth. It's slowly spiraling out. And as we have in this little cartoon, I feel we're drifting apart. And that's because of because of the tides. The Earth spins in 24 hours. The moon takes 29 days, roughly, to go around. So the Earth and its tides is always kind of rushing ahead of the moon. And that tidal bulge pulls on the moon and flings it out a little bit every interaction, every orbit. And so that is actually sending the moon farther from us. At the time that life formed on Earth, the moon was 3 times bigger in the sky. And at the time that the moon formed, it was 16 times bigger in the sky. So imagine going back 4.5 billion years and seeing that moon. But this, of course, is what our moon looks like today. And the question arises, how did we get this gorgeous, brilliant, bright, and beautiful moon? Now, a lot of the planets in our solar system have moons, but the Earth is the only one that has, well, the inner ones has this very large single moon. Here's just for comparison of the size of the Earth. The moon is about a quarter of its size. There are larger moons out around Jupiter and Saturn, but they are around much bigger planets. So by proportion to the size of its home world, our moon is unusually large. We're almost like a binary planet. It's a very, very large world. Now, when I was younger, we didn't know how the moon was formed. That was before Apollo. We thought, was it ripped out of the Earth? Maybe it formed at the same time that the Earth was formed. Maybe we captured it, and it was just flying by, and it got captured into Earth's orbit. We really didn't know. But now we know that the way the Earth and the moon formed was very early in the formation of our solar system. Shortly after the Earth was formed, a large Mars-sized object that they've nicknamed Theia crashed into Earth. What a bad day on Earth. Excavated up all this debris, and in a comparatively short period of time, maybe a year, maybe as long as a century, all that debris coalesced into the moon. So here is a model done by one of the leading astronomers, Robin Canup, who developed this model that shows a computer simulation of that impact. So look what it did to the Earth. The Earth is all glubby there. And then you can see all these hot particles coming out. There's this one big glob that crashes back into the Earth and raises up even more debris. And then there's one more object that comes in a minute, gets tidally stretched out. So you've got this whole disk of debris circling the moon, circling the Earth. So for a while, Earth had a ring. Not for a very long while, but for maybe somewhere between a year to 100 years until that ring of debris coalesced into the moon. So here are some pictures just from that simulation that shows how destructive that was to our planet. Kind of crazy to think about. All of that happened 4.5 billion years ago. We know that this is true, or we should say that there is a lot of evidence that supports this model. This is a widely accepted model now as to how the moon was formed. And one of them is by looking at the compositions of moon rocks. In many ways, there's a lot of similarity between the compositions of the rocks on the moon and the rocks in the crust and mantle of the Earth. That suggest that they come, but not similar enough that they would have formed together. They're different enough. If the Earth and Moon had formed together, they would have been identical, made out of the same stuff. But they're similar enough that suggests we've just excavated off the crust and mantle, and we know that from getting moon rocks from the Apollo mission, bringing them back and analyzing them. Another interesting thing is that our moon and Earth have very different sized metal cores. When you get big planets that are around, a phenomenon called differentiation takes place where the heavy stuff, the metal like the iron core, sinks to the center, and the lightest stuff, the crustal material, stays on top. So the moon has a really tiny, tiny core. And that's because in that collision, we scraped off a lot of mantle and crust, but we didn't get a lot of metal from the Earth's core. So the moon's core is very small. And the flip side is that the Earth's core is very large compared to the size of Earth. And that's because Theia, the thing that crashed into us, it's believed that the core of Theia got blended into the Earth's core and made our Earth's molten core much larger than it would have been had there been no collision with Theia. So it's kind of crazy, but that's what it predicts, and there are a lot of other predictions. We know the lunar rocks were molten and have had this history. We have age-dated things. We now know the moon is very old, again, thanks to the Apollo rocks. So this picture all holds together and is always being modified to get finer and finer details. So I'm just going to show you a quick video from a planetarium show we did a couple of years ago called Time's Up, simply because rather than see the computer model, we animated it. And the reason it's in this weird round format is that we used to show it on our dome. But it's kind of pretty, and it shows the formation of the Earth and the very rapid formation of our moon. So that's the solar nebula out of which the Earth was formed and all the other planets and our sun. There we go. Moon. That is the late heavy bombardment, and I will tell you about that in a minute. So, just a little artwork to show you what the first 500 million years, all condensed down to 20 seconds, was in our solar system and in our planet. So another question about the moon is, how come there are so many craters? The moon was peppered with impacts, and so was Earth. But Earth has plate tectonics and atmosphere and water that has weathered most of that away. The moon doesn't have that. So we have a record of all of the ancient impacts that hit the moon throughout the moon's history. So we now know, in that animation I said that's the late heavy bombardment, that there was a period about 500 million years after the Earth and moon were formed that suddenly the inner solar system was just peppered with junk flying in and crashing into the inner solar system. Mercury also shows the same record. And that event is called the late heavy bombardment, and it comes from this crazy moment in the early solar system, and it is kind of a moment, and I'll show you that in a second, that that when the solar system was forming, the outer planets, Jupiter, Saturn, Uranus, and Neptune, actually were in a different order. In the early parts of our solar system, it was Jupiter, Saturn, Neptune, and Uranus. And then at a very special moment, Uranus and Neptune flipped places. So you can see Neptune's the blue one. There's inside Uranus, and there's all this white, all these little particles. This is, again, a simulation referred to as the Nice model because it was first developed in Nice, France. So in our early solar system, that disk of debris all surrounded our solar system. We on Earth are way down into the center. But it was in order Jupiter, Saturn, Neptune, Uranus. And then something happened to cause, as a friend of mine would say, cause the solar system to go catawampus. It just kind of went nuts. And what that was that Jupiter and Saturn came into a resonance. How many of you sing in the shower? Okay, thank you for admitting you sing in the shower. And if you do a scale, you usually, if you go, ooh, there's a note in which your shower just resonates. It gets really loud because the wavelength of the sound reinforces, it's the same number of, even number of waves in your shower, and it amplifies. Is that a familiar idea to you, that you can amplify waves by having it be in a resonant space? If that's not familiar, go home, sing in the shower. I promise you, you'll hear it, that there's a note that is the best, loudest note you can sing. And you could go home and find it. So that kind of happened in the solar system. It wasn't singing in the shower, but this resonance took place where Jupiter and Saturn got into a rhythm together. And together, they pushed on Neptune, the extra energy of tugging on Neptune, and sent it flying out beyond Uranus. When it did that, it disturbed all of these guys, and they all fell into the inner solar system. So I'm going to show you a little simulation again. This is a mathematical model that goes on. You can look at the time scale at the top. We're looking at hundreds of millions of years. I sped it up because who wants to sit around for a minute? And then all in a second, you'll see very briefly, boom, 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 1, 2, 3. See how the blue line goes out, scatters all those particles. It sent a shower of debris into the inside of the solar system and a shower of debris to the outside of the solar system that we see today as the Oort cloud. Explains a lot of other things, Trojan asteroids, asteroid belts. There's a lot of details to be worked out. But basically, here's the story. For a while, it was Jupiter, Saturn, Neptune, Uranus, and then boom, very, very short period of time, they changed places and sent a rain of debris. So that might not be something you've heard about. You can go tell your friends about the late heavy bombardment and sound very cool. But here's the other cool thing about it. As you might imagine, it made the Earth quite molten. We got just pummeled. Forget about the dinosaurs. That was, a day in the park compared to what happened during the late heavy bombardment. But as soon as Earth cooled after that, we believe life formed on Earth. It's kind of crazy because the Earth would have been inhospitable to life, But then it cooled. After the late heavy bombardment, we have our earliest record of the origin of life on Earth. Suggests that life happens easily, readily. As soon as Earth could host life, it did. So that late heavy bombardment, of course, led to this very rough terrain on the moon. And today you can go outside and make craters on the moon yourself. Here's a little video from the other day. We have this going on out on the lawn. And see, you just imitate the late heavy bombardment and drop a...
So you can see how my crater...
Simple. It excavates stuff from below and sends out those rays. Oh, he wanted a big crater. Who can blame him? And you have to say boop. So anyway, that's what's going on there. Moving on, you can see that the moon is made of lots of different terrains, lots of craters. These different colors code to different types of material. There's a lot of different geology going on the surface of the moon. There's volcanism, old records of ancient volcanism, and these rills. There are these strange, like river-looking things. They're not carved by water, but are geological features simply from the way the rock shifts. Even rift valleys on the moon. And of course, we brought back rocks to be able to understand how old the moon is, study their different compositions, and learn all of these things about the Earth-Moon system. Here is a picture of a rock on the moon that was brought back by Apollo 14 that was thought to be, and is thought to be, the oldest rock on the moon. And moreover, it's thought to have come from Earth. Its composition is actually more like an Earth rock than a moon rock. So I love the idea that something hit the Earth, propelled a rock to the moon, and then the astronauts brought that Earth rock back from the moon to the Earth so we could study it. Now, one of the last mysteries that I want to mention is vital for our future on the moon if we are going to go back. And that is that if we're going to be able to live and work on the moon, we're going to need to be able to have supplies on the moon to keep us alive. And so there is a great lot of work being done on looking for water on the moon. It was thought that the moon was bone dry, no water whatsoever. But even with Apollo, there were some very early indications that there might be some water on the moon. The real first evidence and strongest evidence came not during the Apollo era, but the first time we went back to the moon. The United States went back to the moon with a mission called Clementine in 1993. And they did a survey of the entire moon. This was actually a mission that was supported by the Strategic Defense Initiative, if anybody remember what that was. It used to be called Star Wars. And I know the guys that did this mission, and yes, it was a technology proving for sure, but they just really wanted to go back to the moon. It was a big part of it too. So they developed the technology, mapped out the moon, and found evidence that in these craters, this of course is a map of the moon but stretched out. So you know, like when you have a map of the Earth stretched out and then Greenland looks huge, the United States looks small, and Antarctica looks huge. It's the same kind of thing. These craters are just stretched out because this projection is rectangular. But they mapped out all of the materials on the moon and saw evidence that suggested that maybe there might be water at the South Pole in those craters. And that's a very reasonable and likely place to have it. Another mission, an Indian mission to the moon, Chandrayaan, confirmed that, took further observations, and they also did, this was at the first part of the 21st century, they took more measurements and also found evidence that the poles could be water rich. And then we sent a mission in 2009 called Lunar Reconnaissance Orbiter. And part of that was a sort of not an add-on, but an experiment called L-Cross. And what they did is crash. They had the upper stage of their Centaur rocket, and they crashed it, deliberately crashed it into the moon at the poles to raise up a little plume of stuff. And then the little spacecraft flew through the plume. And sure enough, they measured water. So we know that there is water on the moon. And this is very exciting and important for possible future habitation. The reason water is able to stay on the moon is because the moon has permanently shadowed craters at the poles. So that we're now looking down at the South Pole. The angles are so steep, you can see some of these craters never see the light of day. There's no light, the sun never gets to them. And so this is just a little map, a little overlay showing the distribution of permanently shadowed craters. There are lots of them. And we now know that in those permanently shadowed craters, there is evidence for water ice. So this is, if some of you are aware of the Artemis program that we'll be talking about this afternoon, NASA's next mission to the moon, they are targeting their mission to go to the South Pole of the moon because that's where they think the water is. And that's where, if we're going to be able to set up any human habitations or space settlements or anything like that, we're going to need to be where we can get water from the moon. And that is the plan with this. A few last little items. The South Pole is home to one of the largest impact craters in the solar system. It's called the South Pole Aitken Basin. And you can see it's pretty darn big. This is actually a depression. It's about a little over a mile deep in the middle. One big, huge crater. And you can see the South Pole is right on the edge of it. And a couple of new things, actually just from about a month and a half ago, is we have measurements now that show us that there's a big deposit of, well, there's a very strong gravitational pull underneath that basin, which suggests that whatever smashed into it is lodged just inside or deep inside the moon, but at this spot. So while it's a big crater that's excavated, as a spacecraft falls over, it feels a little bit more of a tug. There's an extra gravitational pull from something underneath the Aitken Basin. And this is new results and new research. Everyone's scrambling to try to understand what it could be. The other thing about the moon that remains a mystery is what the mantle is made of. We've only got rocks from the crust. We've never been able to get down lower and measure what the mantle is, which is key to all of these models that we're talking about. But the Chinese just landed a mission called Chang'e 4, and it has a little rover called U-22, which is always fun to say. And it is I should have pointed out, in Shackleton Crater, very close to the South Pole in the Aitken Basin. I don't know which one is Shackleton. I should. Might be that one. And so they have just announced, as you can see, this is just in May of this year, some new results that suggest that, in fact, in that Aitken Basin area, material from the mantle, because of that big impact, has been excavated up, and they may be able to get and are starting to do analyses of rocks on from the mantle, which is new and very, very exciting. So we're still trying to piece together even the layers of the moon, the mantle, and the history of the moon, and this will probably play a very important part to it. So I'm going to finish with just a kind of a cool video that shows the history of the moon. It will go from after its formation, so we won't be redoing the formation, but I'll just let it play. It was created by NASA, the Lunar Reconnaissance Orbiter mission that I mentioned. Oh, by the way, Lunar Reconnaissance Orbiter, launched in 2009, still active today. And in the next talk, the hoax, no hoax, you'll see images of the Apollo landing sites taken by Lunar Reconnaissance Orbiter from orbit of the moon. So it's still a very active satellite and bringing us very important results on the moon. Anyway, here's this cool video put out by that mission that shows the lifetime, the history of the moon. There's the Aitken Basin. And you see those other red areas. Those are lava fields, which are now the dark parts of the man in the moon. And that brings us our moon as we see it today. So those dark parts that we think of as the man on the moon are called mare because ancient people thought that they were seas, but they're not. They're ancient lava flows from early in the moon's evolution. So you have the ancient highlands that are even older, the mare that covered part of the face of the moon, and the craters and all of the cratering events since. And that's what you see when you look up at the moon today. So that is all I have. I have time to take maybe 2 or 3 questions if you have any. And if not, I will invite you to come back to the rest of our talks. I promised I'd get you out in time to get to the Planetarium Show. So are there any questions? Yes.
So are there rare earth minerals on the moon, and do they think they come from the moon or they're from Earth?
The question is, are there rare earth minerals on the moon, and do they come from the moon or from the Earth? Most of the rare earth, there are some rare earth minerals that are both from the Earth and Moon that were present at formation, but a lot of that was delivered later from bombardment coming in from the outer solar system. So that clearly is the rare earth minerals are really important minerals to our future. We need them for all of our, a lot of our green technologies, our batteries, technologies, all that sort of thing. So clearly that's something that people are interested in mining if they were able to find it. There's also some interest in mining helium-3 on the moon that would give us fusion power. That's yet to be demonstrated, but yes, there are a lot of people interested in mining the moon in the future. Yes?
In regards to the mining on the moon, is there any kind of international laws at this point to stop any of that? Or has there even been any kind of discussion on how the governments would cooperate or companies would cooperate if there should be any kind of encampment?
The questions about what are international agreements and laws that provide a framework for potential future development of the moon, mining, and so forth. And there is the Outer Space Treaty of 1967 that basically declares it's for all mankind. And there is a whole field called space law that people actually go into and have their whole careers around because there are so many, and it's going to be coming back in full force, especially with the push of private sector to go forward. I think we saw with the Starlink, which is this satellite constellation that SpaceX is developing, that the private sector is moving faster than the regulatory environment is. And so I think this will be an extremely active area in the next 5 to 10 years. And you've asked a very prescient question, but it is by no means settled, and there is no enforcement really in place. And basically it hasn't been pushed because nobody had the technology to go back and do that. But as people start getting back to the moon, I think that will become quite an important issue. Okay, I think with that, I'm going to let folks go because it's 12:30 and we'll let them get to the Planetarium Show. So I want to thank you again for coming. It was lovely for you to be here. Have a great day at Griffith Observatory.